Hello everyone. In today's video, we are diving into something super exciting called Retrieval-Augmented Generation or RAG. But before we jump into what RAG actually is, let's rewind a bit. You have probably heard of large language models like ChatGPT, which are trained on tons of public data available from books, websites, and forums. That's important to note. They don't have access to your private data, and they also don't automatically update themselves with new information. Once a model is trained, it's frozen in time. These models are amazing at answering questions, summarizing content, and even writing code. So what does that mean for you? It means these models are amazing at answering general questions and giving creative help, but they can't access private company documents or learn about recent changes unless they are trained, which is time consuming and expensive. That's where the problem lies. It's like having a genius who read a billion of books but nothing published after 2021. Now imagine if you could hand this genius a few up-to-date documents right before answering your question. Wouldn't the answer be way more relevant and accurate? That's exactly the idea behind RAG. RAG stands for Retrieval Augmented Generation. Instead of just relying on what model already knows, it fetches the most relevant information from an external source, like a database or a document, and uses that to answer your question. In this video, we will walk you through how this RAG pipeline works one step at a time, from reading documents to generating answers. Let's get started. Alright, now that we know why we need RAG, let's talk about how it actually works behind the scenes. Think of RAG pipeline like a smart assistant who first read a bunch of documents, remembers the important points, and then gives you most relevant answer when you ask the question. This entire process is broken into several clear steps, and each one plays a crucial role. Here is a bird's eye view of full RAG pipeline. First is parsing. It reads raw documents like PDFs, website, or spreadsheet and turns them into plain text. This is like converting a messy file into plain and understandable text. Second is chunking. It breaks that big text into smaller chunks. This makes searching and processing much more faster and more accurate. Third is embedding. Each chunk is converted into a special mathematical format called vector that captures the meaning of text. Basically, the machine now understands what each chunk means. Fourth is vector store. These vector store these vectors are stored in a special database that can quickly search and find which chunks are most relevant to the question. And our last step is retrieval plus generation. When someone asks a question, the system first retrieves the most relevant chunk from the database and then the language model uses those chunks to generate an accurate and context-rich answer. So, instead of depending only on pre-trained knowledge, this system grabs useful info just in time and blends it into the answer. In the next video, we will start building this pipeline from scratch, starting with how we get the data ready using parsing and chunking. Till then, stay tuned.